Let's go through leak 1915, number of wonderful substrings. For this question, it gives us a string word and define a wonderful string is a string where at most one letter appears an odd number of times. So for example, CCGGC, and here G appears once, and the G C is character appears all times, and there is only C appears once, and G appears even times, and also AB because A appears even times, B appears even times, so none of those character appears more than once, and AB both A and B appears once, that is even times. So AB is not a wonderful string. So it allows us to find how many substrings which of a word it's an wonderful substrings. So for this question, it gives us and it says that those kind of word is consists of 10 lowercase English character from A to J. Instead of from A to Z, 26 combinations. Here we can see it only give us to have 10 different options for the character. So for 10 different options, why give this small range? Sometimes when we think give this kind of condition, we can give have some kind of hint, because if it's 10 digits, right? And if binary for 10 digits, it's smaller in a range, in an integer range, right? So this one give us some kind of hint that for every if we have 10 characters, right? 10 characters to J, we can use some kind of binary format to represent it. And also, you see that those kind of numbers, those kind of character, for example, the odd number appears at most once, right? So for the odd and even, we don't need to care about those kind of numbers and how many times it appears. But in the binary operation, there is kind of XOR operations. For example, a character, if it appears even times, right? So C XOR C will be 0, right? And if it appears odd number, it will become C, right? So what we're thinking about is that we can use some kind of binary representation to see how many to represent for those kind of, for example, this A, right? To represent whether it is this character appears when it appears even times or odd times, right? So for example, if there is A here, we find A character, then we'll say we put this one as 1. And if there is B, right? So the from the right to left, the second bit, we put 1, right? So this C, right? And until to J. and this become 1. So if it appear once, we put this 1, right? And if it appear twice, that means this is even. Then 1 XOR 1 will be 0, right? So what we're thinking about is that if there is a state with this kind of state, for example, 1, 1, 0, 0, 1, 0, to represent those kind of characters, right? It appears how many times? Even times or odd times. So if in, for example, when for this word, right? If we have this word, if we come to this I, we have some kind of state. For example, it is 1, 0, 1, 1, 0, and then to J, right? It comes to this 1, 0, 1, 1, 0 again. So what does this mean is that from I plus 1 to J, right? All the characters appear all even numbers, right? Because XOR does not contribute that state. So what we think about is that we can use some kind of prefix sum to represent the state, right? The key will be the state, and the value will be this kind of state, how many times it appears. So the question, let's get it to simplify this question to ask, for example, it says that beautiful string is that the odd, a character appears odd number, be at the most once, right? So if we are trying to simplify the question is that how many substrings, all of the character appears even numbers, right? So that we just use prefix sum to have the state as a key, and how many times it appears, right? So when we iterate, if we find this key, then we count these values, right? That means in the previous state we have we sim this state. So that means from any of the previous index which show this state to current index, those kind of substring have all of the characters have even numbers, right? So this is a prefix sum problem which we seen before, that to count the times, right? There are a lot of similar questions, and for the prefix sum, the map, right? We can have the state, for example, state 0 as initial, it appears once, right? And every time there is a character coming, we XOR the ith digits. For example, if it is a C, right? Then the third digits we XOR with 1. And when we iterate through those kind of I to the end, if we see this state appears again, right? That means from this I to the previous one which have this kind of state, it will have all of the even numbers, right? So we use a count as a values, right? So that means for this I, we can at least have this count of state to have all of the numbers to appear even times. And for this question, it has another condition, is that it's not asking all of the numbers appears even numbers. Not all of the character appear even numbers, but that the things that we are allowed to change one of the character to be odd number, right? So what we can do is that, for example, every time we iterate to this kind of state, we find whether this kind of state, how many times it appears, right? So this is one part of our solution is that that means we have how many substrings, which all of the characters appear even numbers. And another is that at this state I, we're trying to change one of the 1 to 0, or we flip one of the 0 to 1, right? And that means we can that means for the state changes, new state, right? And there is only one character difference. That means if we in the map we have those kind of changed state appears from here to our new I, right? There is only one. The other characters are all even numbers, but the flipped one is odd number. So we need to do two things. One is find all of the numbers which appears even numbers. Right? Another is that we flip each of the bits here, right? Trying to see whether how many, trying to see the counts for this kind of states, how many times it appears, and add it to our result. So let's, after this analysis, let's begin to write code for this, right? We can use map to represent state and counts, right? So we can use the function map. It can be long, right? And how many times it appears, we can also have long, right? We will find this kind of state, it will less than 10 to the power 10th, right? So actually we can use what? We can use a long array to represent the map. Equal prefix sum equals new long 2 to the power 10th. So that is actually we can write this, right? Left shift 10. So you can also write 2 4, right? And for this, we need to put the initial state, right? So that one is that the 0 state. That is, we don't add any character. It appears once, right? And let's have a sum equals 0, right? And we need to have a long result equals 0. Right? So what we do is that for every character in word, which array. So what we do is that we'll have this sum, right? Should XOR 1 left shift C minus this A, right? So that means if it is A, we XOR these bits, right? If it is B, we XOR these bits with 1, right? So for this state, we need to check the prefix sum map, whether it appears or not, right? So we'll have a result should plus equal to prefix sum. Right. That means from this appears, for example, how many times it appears. Of course, after doing this, we have prefix sum should plus, right? Because for this kind of state, it increase one more times, right? So if doing like this, we can get all of the substring numbers which have all of the character appears even numbers. Now we allow one of the character appear once, appear odd number. So what we can do is that we can flip, right? So we can flip one of the bits from 1 to 0 or from 0 to 1. So what we can do is that for int I equals to 0, I smaller than 10, I plus plus. So the flip is we can have a int new sum equals sum. Flip is also XOR, right? XOR 1 left shift I, right? So then we need to check if this new sum, how many times that appears. We also need to add to our result. So our result is equal to prefix sum new sum. So this is our result. Okay. So the time complexity will be ON, right? But space, this is long, right? 1024 prefix sum. This 01024, this kind of length, right? And we can also convert this to Python code. So we'll have prefix sum equals 0 multiplied by 1024, right? And we know prefix sum 0 equals 1, right? And let's have a sum equals 0. We can have sum variable, sum value. P sum is 0. And result also equal to 0, right? So what we do is for C in Word, what we are going to do is P sum to the XOR equal to 1. We should left shift for this character. We need to use order, right? Order C minus order A. So we have result plus equal to prefix sum P sum. Okay. And also we can flip one of the character, right? So what we do is for I in range and we'll have new sum equals P sum XOR 1 left shift I, right? And we should have a result plus equals prefix sum new sum. And after adding these two parts, right, our results will have two parts. One is that we do not flip any character. That means every character in for those kind of substring appears even numbers. And this part is we allow one of the character to appear odd number. And also we need to update the frequency map, right? So prefix sum right? Should P sum plus equal to 1. And then in the end, the return result. Okay.